This is the first video on volume of solids. It's looking at prisms. Here we see a centimetre cube. The sides are 1 centimetre. The volume is 1 cubic centimetre, and each face has an area 1 square centimetre. If I was to put 10 of these together, what we have is a volume of 10 cubic centimetres, and the front of this arrangement here in yellow has an area of 10 square centimetres. So its volume is 10 cubic centimetres because it's 10 little cubes. The front face of each cube is a square centimetre, and this is 10 of them. So 10 square centimetres for the front face. Volume 10 cubic centimetres. If I put another layer on, so it's now 2 centimetres deep, its volume's 20 cubic centimetres, 2 lots of 10. Third layer, 30 cubic centimetres, 3 lots of 10. 40 cubic centimetres, 4 lots of 10, and so on. There's 60 cubic centimetres because its depth is 6. So every time I put another layer on, I'm increasing the volume by 10 cubic centimetres. The face here is 10 square centimetres. The depth of the arrangement here is 6 layers. That's 6 lots of 10. So it's like the end face being 10 multiplied by 6 centimetres deep, giving you 60 cubic centimetres. So if we continue this all the way to the end, 12 layers, 12 lots of 10, 120 cubic centimetres. So you can think of 10 square centimetre area times the 12 centimetres deep. This is a prism. It's a shape where this area stays the same all the way through the shape. So for example, if I were to cut off the part of the shape part way through, this cross section's the same. It's this 10 square centimetre cross section, identical from front to back. A shape like that's called a prism. It's the same all the way through. The word comes from the Greek word prisma, to cut or saw. So if you sliced it, here it's been sliced, you would get this same cross section all the way through the solid. So the volume was the area of that end face multiplied by how deep the prism was. You can call that its length or its depth, or could just use height here, h for height, but it doesn't mean vertically, it just means in terms of depth. So area times height gave the volume. So that applies to any prism. It's important that the prisms are of a type where the area here of the base and the height are at right angles to each other. They're perpendicular. So area and height are at right angles. And when you carry out calculations, area times height, you must match up the units. So whatever the area units are, let's say they're square centimetres, you need the length units for the height here to be centimetres to match it, so you get cubic centimetres for your volume. If the front face was in metres, the depth has to be in metres, and so on. So here are some prisms. This is a circular prism, a cylinder. Anywhere I slice this cylinder along its length, along the side labelled H, it's the same cross section all the way through. It's this circle from front to back. So that's a prism. It's the same cross section all the way through, as long as you cut it parallel to the end face. Here's a pentagonal prism. The area is shaped as a pentagon. That area is the same all the way down through the shape. Here's a triangular prism, front to back. Wherever you slice it, you get this triangle, as long as you slice it parallel to the end face. This is a composite. It's got a rectangle and a semicircle combined. From all the way through, it's the same cross section all the way through. And this is a hexagonal prism because of the hexagon in the end, and it's the same all the way through. So there's an area of a base, that shape's the same all the way through, and it moves along what we're calling the height or the length. So here's a set of prisms. There's this area here, shaded yellow, and at right angles to it, that's the height or the length of the prism. that red line. So in this one, its front face is 80 square centimetres, its height or its depth or its length is 30 centimetres. Simply multiplying these, area base times the height gives you the volume. So you just do 80 times 30 and you get the volume. In cubic centimetres, because it's square centimetres multiplied by centimetres. In this one, it's mixed units. It's not 2 times 80, that's 2 square metres. This 80 centimetres has to be turned into metres. So it's actually 2 times 0.8 metres to get cubic metres as the answer. This one's fine. It's 4 metres matching the square metres. So 4 times 1.5. This face is a trapezium. Its area is 800 square centimetres. The depth, or the height, as we're calling it, is 3 metres. To match the units, the 3 metres must become centimetres. So it's 800 times 300 centimetres, giving you cubic centimetres. This one here, square millimetres for the area, you need millimetres for the length. So you need to turn that 2 centimetres into 20 millimetres and you get an answer in cubic millimetres. So you've got to match the units. So here's a triangular prism. You want the volume, you get this area. That's for a triangle, half base times height, base 12, the height of the triangle is 8. So once you get that area, the volume of the prism is area of base multiplying height, which is the depth of the prism, the length of the prism if you like. So in this calculation it's 12 times 8.5 it for the area, and then it's simply that area times its length. So put V equals A times H. Remember, H is the length of the prism. So it's 48 times that, 20. Here, this end face is a trapezium. That's covered in the videos on area, where you get this formula. A and B are the parallel sides, they get added. The height is the height of the trapezium, which is the distance between the parallel sides. That's the 15. So, calculation for the area of this yellow trapezium is add 6 and 14 the parallel sides, multiply it by the height and half it. So that's 15 times 20 for the brackets divided by 2. That area is 150 square centimetres. The volume of the prism is that area of the base times its depth, its height. So we're using V equals AH here. 150 the area times that 12, and out comes the answer in cubic centimetres. Now there'll be a worksheet you can get if you click the link in the description, and it will practice questions just like these. It will be involving various end faces, triangles, circles, part circles, the trapezium and so on. The main bit of the calculation is finding the area. Getting the volume is quite easy. It's a simple formula, V equals AH. You simply multiply the area by the length of the prism, the height, the depth. So the main calculations are calculating the area. So for any prism, you need the area of the end face and the depth of the prism. For cylinders, where it's a circular end face, since we know area of a circle is pi r squared, most usually this formula gets used. The A gets replaced by pi r squared, and we use V equals pi r squared h. So pi is usually off the calculator, approximately 3.14. R is the radius of the base, and h is the height. The height's, wherever we could slice it along the height, it will have the same cross section. So height is at right angles to the base. So this formula, if that was 15 in height, that's h is 15, and this is a diameter 12, so radius is 6. So we use V equals pi r squared h, with r being 6 and h being 15. You just slot it into the formula, put that in the calculator, round off the answers appropriate. This is actually rounded to 3 significant figures, but since the 9 is followed by a 6 making it round up, it rounds to 1700, which is 2 significant figures. So it's been rounded to 3, but it's ended up with 2. So it's a simple formula, and you simply put in r and h and follow it through. when we're doing these, if we are using pi and we don't replace it and leave it as pi, we're getting what we call the exact value, because pi off the calculator is still only an approximation. So it says these two cylinders have the same volume. So you can work out the volume of this first one because you can get the radius and the height. And the second one, using that volume, you have to work back and get the height. So for the calculations here, V equals pi r squared h. R is 5, half that 10. H is 20. And this time, we don't replace pi. We do 5 times 5 times 20, which gives us 500 pi. So that's the exact value. This volume of the one on the right is 500 pi. So if you use the formula, put 500 pi for the volume, 10 for the radius, half that diameter, and h is the unknown. You now just tidy that up, and to get h, you divide the 500 pi by that 100 pi, and it comes out exactly 5. So no calculator needed there. We're using the exact value, so the answer works out exactly 5 in this case. And this is a composite. So we've got an end face, which is a semicircle, and a rectangle. So that yellow area needs to be calculated, and then we can use the volume of the prism, V equals AH. So there's the two parts of the yellow end face: a semicircle, area, pi r squared and half it, and a rectangle, length times breadth. So pi r squared, r is 2, that's a diameter 4. So the area is 4 pi for a full circle, half it for a semicircle, that's area 2 pi. This of course is 4 times 10. And then we can add the bits together. So it's 2 pi plus 40. In the calculator that'll come out 46.283 and so on if we replaced it. Use that unrounded figure. The depth of the prism is 15, so that's the h in the V equals AH. And you simply follow that through, rounding it off, 3 significant figures, 694 cubic centimetres. So prisms, there's an end face, and that shape continues all the way through the prism, and the main calculations are calculate the area. 2 worksheets can be accessed using a link in the description. First one is just straightforward, gives you some areas, gives you some heights, whether it's call it height or length or depth. You've got to watch the units. You've got to work out the area, the end face, and then use V equals AH. So after that, number 2, it's calculate the area in yellow, and then you can get the volume. And some composites, and then some cylinders. And it'll have the answers. Second is a much more difficult worksheet. It's got lots of questions. In every case, you have to find the area of the end face first. So that's going to be like this one, where you worked out this part in yellow. And when that's worked out, then you can get the volume by V equals AH. So the first bit's get the area. That's the main bit of the calculation. So triangles there on the end face, combination of rectangle and triangle. Trapezium here on the end face. This is a hexagon, but it's actually two trapezia stuck together. So you can actually split this into, the hints in the question, there's a triangle on top here and a trapezium on the bottom. So known shapes that you met if you looked at the videos on area. Cylinders and variations on it, combinations of parts of cylinders and the cuboids, but what you do is you want the area of the end face, rectangle plus semicircle, and eventually working backwards, told the volume, work back to a missing dimension, and the answers are with them. You can also use a link description to get the notes on volume. That's all brought together. All the videos on volume are covered by the notes. That's the first video. Hope you found it useful. The next video is on pyramids.